Hello all, this is Mr. G, and in this video we're answering one question. The question is, do all systems have a unique solution? What we mean by unique solution is one collection of values, one value for each variable that will solve the solution, one and only one. Now, hopefully if you're thinking about this, well, no, of course not. We've already seen in previous videos that we've already seen systems of two variables that have had no solutions, and we've seen systems of two variables that have infinitely many solutions. So we've already seen examples where a system does not have one unique solution. But how does that look with a three variable system? So what we're going to do, we're going to try and solve this system using matrices and see what happens. So I'm going to do it both ways. First, let's use the inverse method. So I'm going to hit second matrix. That's not the matrix button. Second matrix. There we go. I'm going to go over to edit, and we'll make matrix A our 3 by 3 right there. So let me see, 3 by 3, and it's going to be 2, 3, 4. Just entering the coefficients. I missed the 3 somehow. 2, 3, 4. There we go. Then 5, 6, 7, 8, 9, 10. Nice and arithmetic, that pattern. There we go. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Now matrix B, so second quit. Go to second matrix to open the matrix menu. Go over to edit. We're going to edit B as a 3 by 1 with the constant, what's on the right side of all of our equations. So 3 by 1, and it's negative 5, negative 11, and negative 17. 5, negative 11, negative 17. Okay, now we hit second quit. Now we just do the inverse of matrix A times matrix B, and that will give us our answer. So second matrix, enter to bring out A, hit the inverse button, times second matrix, let's grab matrix B by hitting 2, and then we hit enter, and we get an error, a singular matrix error. Essentially, this means there's no unique solution. No unique solution. There might be infinitely many solutions. There might be no solution at all. But this one phrase, no unique solution, sort of is a blanket statement that covers all of those possibilities, whether infinitely many or no solutions at all. There's no unique solution. Now, it might seem like this video is done, and maybe it sort of is, but there's one other thing I want to show you. Because if we go to second matrix, if I hit enter, get out of there. Let's say we use the RREF method. We did not use the inverse matrix. So I'm going to go to second matrix. Now we're going to go to edit, and we're going to edit A as a 3 by 4 this time. So this is the method that's a little bit faster, where you're able to put the entire system in the calculator as one matrix. So a lot of this is going to stay the same. The first 3 rows and columns will stay the same. But the last column, the fourth column, needs to change to a negative 5, a negative 11. Uh-oh, that's supposed to be a 5. Now things are going haywire. Delete, delete, delete. That's supposed to be a 5. Enter. I should have hit down, not enter. So negative 5, negative 11. Let's hit down this time, and negative 17. Always want to be careful that we enter our numbers correctly. So negative 5, negative 11, 17. I'm going to double check one more time that I didn't, that I fixed that mistake I made. 2, 5, 8. That should be good. Yeah, just checking that first column there, 2, 5, and 8. Now we hit second quit, and now we get our reduced row echelon form operation. So second matrix, go over to math, go up until we see RREF. I think that's reduced row echelon form. I always forget the name of this. Then second matrix, go grab matrix A, which is number 1, hit enter, and it looks like it's giving us an answer. It looks like it's saying, oh, x equals negative 1, y equals negative 1, and z equals 0, because usually when we use this method, our answer is right there. But the problem is, if you're not looking carefully, you will have forgotten to check this. When you're using the RREF operation, you have to see that the first 3 columns are 1, 0, 0, 0, 1, 0, and 0, 0, 0. Those are that first 3 by 3 has to say that. So we need the ones in a nice diagonal line and the rest zeros. We don't see that here. We've got a 1, 0, negative 1. As soon as you see this negative 1, you think, wait a minute, that is not supposed to be there. So that is essentially the calculator's way of telling you that this did not work. There's no unique solution. So if you're going to use the reduced row echelon form operation, you got to be real careful, because if there's a no unique solution situation, it could very easily look like it's giving you an answer if you forget to check for those diagonal ones. I went the wrong way. My camera's backwards here. Forget to look for those diagonal ones and the zeros in the first three rows and columns. All right, that's it for this video. Hopefully that made sense. If you have got questions, let me know. Enjoy the rest of your day.